Okay, so we are ready for our first set of notes in Unit 3, so you need to flip to Unit 3. The first set of notes is going to be on page 29, and it's going to be titled Solving Absolute Value Equations. And I abbreviated absolute value with just capitalized AV. So once you get that written down, you should be printing this off, or maybe you were given it in class. It doesn't matter, but you need to just take this, fold it down, and tape it onto page 29. So once you get done writing that down, go ahead and do that now. Now that that set of notes is taped into your notebook, we're going to go ahead and start. So again, we are talking about absolute value equations. So I want to lead off with, you talk about absolute value way back, probably 5th or 6th grade. These are absolute value bars. They're just straight up vertical bars. They kind of look like parentheses, but they are not parentheses. So super important, these do not act the same as parentheses. Okay, so let's go back up here to the top. The absolute value of a number is the distance that number is away from 0. So when we talk about absolute value only refers to the distance a number is away from 0. So, for example, if I talk about the number 7, okay? I'm going to talk about the number 7. On a number line, here's 0. You need to be thinking about what are the two numbers that are 7 spaces away from 0. Well, we have positive 7 for sure because there's 7 spaces here, but there's also a negative 7 because this space right here is 7 spaces. It's in the negative direction, but it's still 7 spaces. And distance cannot be negative. Distance is only positive, so that's why we have to take the absolute value of it. Okay, so when we talk about steps to solving absolute value equations, I narrowed it down to 3 steps. So we're going to talk about these, and then we'll actually just dive right into some example problems that I have. So step 1 is to isolate the absolute value expression. So isolate is this first word. And when the word isolate is used, that means that you are trying to get something by itself. Isolation means only you, by yourself. Okay? So when we talk about isolate the absolute value expression, that means that I only want the absolute value expression left on that left-hand side. After you get that done, then you can move on to step 2. Step 2 is rewrite the equation and get rid of the absolute value signs. So absolute value signs. And then I have in parentheses right here, and it's in bold, split into 2 equations. One will be positive and one will be negative. I'm going to talk to you a lot more about that when we get to our example problems. But this is where the distance thing comes into play. So in order to get rid of the absolute value signs, like let's take a look at this 7 example that I did earlier. You have to address both of them. And when it says one will be positive, that's the positive number that you could get. The other one's going to be the negative number that you can get. This is what I'm talking about. So when you address both of those, that's when you're able to take away the absolute value signs. And then step 3 just says solve for the variable in both equations to find the solutions. So step 3 is simple. We've already been working on solving equations. So when you get to step 3, that shouldn't be the new part. The new part is parts 1 and 2. So let's go ahead and look at example number 1. So I have a little like clue box type thing up here. It says don't have to isolate the absolute value expression because it's already isolated in the original problem. So what I mean by that, if we cover the equal sign and everything on the right, is the only thing that is there the absolute value bars and everything that's in it? If it is, then you get to skip step 1 totally. So this one is already isolated, it's by itself, so I get to skip step 1. So step 2 is to rewrite and get rid of the absolute value. So let me show you what this actually is. So it says the absolute value, and I'm going to put my finger in there, of this number. We do not know what this number is yet because it's represented by x minus 5. So we don't know what it is yet, is equal to 9. So remember this little example right here? Well, now instead of 7, let's just make it a 9. So now we need to think about what two numbers on a number line are 9 spaces away from 0. Well, of course, we have our positive 9, but we also have our negative 9. So these are the two options that we have because they are 9 spaces away from 0. So this part right here tells you the distance from 0 that it is. So here's how I do it. Here's how I show it that I'm splitting it. I take this number and I draw 2 arrows away from it, just like this. Now remember, this step right here is where the absolute value bars disappear. We're addressing the absolute value bars. So I have x minus 5 is equal to positive 9. I always do the positive one first because that's the first one that I think of. And then this one is going to be x minus 5 is equal to negative 9. Because remember, it could either be positive 9 or negative 9. We don't know which one it is. It could be either one of these. So that takes care of step 2. And then step 3 is to just solve these two equations that are left. Normally, they are smaller equations and easier to solve. So we're just going to go ahead and solve. I always start with the left one, the one that's positive. So if I'm going to solve this, I need to get rid of that minus 5. So I'm going to add 5 to both sides. When I do that, these 5s right here go away. And I'm left with x is equal to 14. So there's one of them. So that means if we take 14 and plug it back into there, that this equation would be true. So 14 minus 5 is positive 9. So the absolute value of 9 is 9. Okay, so now let's go over here and look at this one. Same thing, if I'm going to get rid of that minus 5, I do the inverse. So I'm going to add 5 to both sides. Those 5s are going to go away. And I'm going to be left with x is equal to negative 4. So now what I want you to see is this negative 4 part. If I were to take that negative 4 and plug it back into my equation, remember this is a solution, so when I do this, this whole thing should be true. So let's just test it. If I take that negative 4 and I plug it in, just like this, we got to make sure it's a true statement. Negative 4 minus 5, that's going to give me a bigger negative, so it's going to be negative 9. Well, remember, absolute value is the distance something is from 0. So what's the spaces, or what's the distance from negative 9 to 0? Well, it's going to be positive 9. So this is 9 equals 9, which is a true statement. So when we're doing these absolute value equations, we have to make sure that we address both of them. A lot of kids, over the years that I've been teaching, a lot of kids will do this one, and they crush this one, but they always forget about the other side of the number line, okay? So make sure you don't. So you could list out your answer choices or your solutions like this. Another way that you may see them written, and this is a very popular way that you have to know and be able to read, is x is equal to, it's the set notation brackets, so it's the ones with the little squiggles. When I do this, I always list them out in numerical order, so I'm going to put that negative 4 first, comma 14, and there we go. So this right here is our solution set. It's called a solution set. So either one of these, you could list them out both like this or in the solution set. You just have to know those are the same thing. Okay guys, so now let's take a look at example number 2. So remember, the 3 steps is to isolate the absolute value, split the equation into 2, and then solve the remaining equations. So when we look at example number 2, I put one of my little hint boxes here that says isolate the absolute value sign. You will have to add 6 before you rewrite the expression. So what I mean by that, when we take a look at this left-hand side, you see how this absolute value, so I'm going to put my finger over that, this is the absolute value. This minus 6 right here is attached to that, and that can't be if we're trying to solve an absolute value. So we need to get rid of that minus 6 before we deal with the absolute value. So this is a minus 6, do the inverse. So we're going to add 6 to both sides, just like that. So these little 6s are going to go away. Now, this absolute value I didn't do anything with, so I'm going to bring it straight down. And I haven't said it yet because I haven't had to draw absolute value bars, but when you guys draw them, you need to make sure that you draw them longer than what you normally draw a 1. Or maybe you can bold them a little bit, because if you draw them short enough, they're going to look like a little 1. So just be careful when you draw absolute value bars. Bring down my equal sign. This side is going to be equal to 10. So now, think back to what I said at the very, very beginning of this note set. Absolute value is the distance from 0. So this number, we don't know what it is yet, is 10 spaces away from 0. So in your brain, you need to be thinking about what two numbers are 10 spaces away from 0. Well, that's 10 and negative 10. So the next step we need to do is get rid of these absolute value bars. And how we do that is split it into each option that it could be, so that 10 or that negative 10. So let's draw our little arrows, and we're going to split our equation here. So remember, at this step right here, the absolute value bars go away. So we're going to be left with 2x plus 12 equals positive 10. Remember, I always do the positive one first. I'm weird, but that's just the way that I like it. And then 2x plus 12 equals negative 10. And now we have two smaller equations. These are just two-step equations, so we should be able to solve both of these. Remember, you have to solve both of them. We have to make sure that we get both sides. So I'm going to start with this positive one over here. And you guys, when you're working these problems out, make sure that you only focus on one at a time. So a lot of kids I've seen, they try to solve both of them at the same time, and they get the numbers a little bit backwards. So what I do, I always take care of the positive one first. So cover this one up. Don't even look at it until you are done with this one. Okay, so now let's just solve this one. This plus 12 right here, I have to do something with it. So I'm just going to do the inverse. I'm going to subtract 12 from both sides, just like that. These 12s are going to go away, and I'm going to be left with 2x is equal to 10 minus 12 is going to be a negative 2. Now, I have to address this 2 that's out there in front of that x, so I'm just going to divide both sides by that positive 2, and I'm going to be left with x is equal to, this is going to give me negative 1. So this is one option. And remember, these are solutions, which means if we take this number, plug it back into our original equation up here, the whole thing would be true. If we were to plug it in, it would be true. Okay, so now let's go over here to the second one. Solve it out. So I'm going to subtract 12 again. But this time, I'm going to have 2x is equal to, this is going to be negative 22, because this is negative 10 minus 12, so this is going to be a bigger negative. I'm still going to divide by 2 on both sides. But this time, I'm going to end up with x is equal to negative 11. Okay? So these are the two values for x that if we were to take them and plug them back in, the equation would be true. It would work out. So we can leave it like this, or remember, you can write them in set notation, which are those squiggly brackets, and as long as you have both of them in there, you can write them. I'll go back and forth between writing them like that. Okay? Now, I want to jump to example number 4, which is straight across the page, because I want to show you what to do with that number that's out there in the very front, and then I'm going to have you backtrack and try example number 3. So take a look at example number 4 over here. Now, this is as worse or ugly as these problems get. A lot of kids, when they get to this one, they freak out and say, oh, Coach Stecker, there's a number out in the front. I don't know what to do with it. So this is why I want to do this one with you. I'm going to tell you what the best way to handle that 5 is, or any number that's out there. It doesn't have to be a 5. It could be any number. Now, the first thing I want to tell you is these absolute value bars are not parentheses. So a lot of kids, they say, oh, well, we're going to distribute that 5. That is not true. These are not parentheses, and we distribute over parentheses. So be mindful of that. Absolute value bars, they work a little bit differently. So I'm going to show you a different way to do it. It's actually a little bit faster. So let's go ahead and start solving this. Remember, step 1 is to isolate, and in my little hint bubble over here, I told you that you would need to isolate, and then I kind of told you what 2 things you needed to do. So here's my trick, and I still do it sometimes to this day, but take your finger and cover up the absolute value part, okay? Any number that's still on the left-hand side with that absolute value, you have to get rid of. You have to address those 2 numbers. So we have that 5 to deal with and this little plus 7 back here. I'm going to deal with the 7 first. You always need to deal with just the number over here by itself first. So this is a positive 7 or a plus 7. So we're just going to subtract 7 from both sides. These are going to go away. And then I'm going to bring everything else down because I didn't do anything with it. Remember, when you draw absolute value bars, make sure you draw them big enough and bold enough that you understand that they are absolute value bars. Negative 8 minus 7 is going to give me negative 15. Okay? So now if I do my little trick where I cover up that absolute value and think about everything else that I have to get rid of, the only other thing is that little 5 right there. So a lot of kids, remember, say, oh, let's just distribute the 5. Please do not do that. There is a faster and better way to get rid of that 5. And remember, these are not parentheses. These are absolute value bars. So the way that I'm going to show you is by division. This is actually 5 times this. So whatever number this is, we're going to multiply it by 5. So if it's multiplication, the inverse is division. So watch this. This is what happens. If we divide both sides by 5, just like this, these 5s right here are going to cancel and go to 1. They're going to go to 1. And then the only thing that we're left with after we do that is that absolute value. So the absolute value is equal to, and then negative 15 divided by 5 is negative 3. And then now we have isolated that absolute value. So then you would, if you need to, continue on. However, we are actually done with this one because of one number. And it's this number right here. And I'm going to write it in blue. This number right here causes us to be done with this entire equation because remember what I told you at the beginning. Absolute value is the distance away from 0. And we talked about how distance cannot be negative. So even if you are talking about a negative number, it's still spaces away from 0. So distance itself cannot be negative. It never will be negative. So this right here, this is what it's claiming, okay? This number, we don't know what it is. The absolute value of this number is negative 3. So remember, this is talking about a distance. We can't have negative distance, so here's what you do. Here's how you take care of this. No solution, because distance cannot be negative. And that's it. Now, as you're writing that down, I want you to listen to me. The state always, always, always gives a question similar to this, something like this, because they know that a lot of kids, when they see this, they'll go ahead and split it and then solve it like normal, and they're going to get 2 numbers, and then boom, they're done. So they're going to anticipate that you guys don't know about the whole distance can't be negative thing, and they're banking on that for you to get wrong. So I'm going to talk about it every time we solve absolute value equations because I don't want that to be you guys on the test. So just remember, distance cannot be negative. It never will be. So if we end up with something absolute value is equal to a negative number, just stop right there, write no solution, and then move on. Okay? So the next one that I want to talk about is example number 5, and then I'm going to let you try example number 3 on your own. So if you're still a little bit confused, stick with me, try to focus on number 5, and then we'll get you to number 3. So take a look at example number 5. I'll move my stuff around. Okay. So example number 5. This one, again, looks very similar to example number 4. We have a number out there in the front, and then there's a number behind. It looks kind of scary. So I want you to try not to focus on that. It's the same steps, same process every time. So, again, I put my little hint bubble over here. If you need help, just look at the little hint bubbles, and then when you're doing your practice problems, you can keep your notes out and look back at these as well. So, first thing I do, remember, I do my little trick where I cover up the absolute value, and then anything that's left I need to deal with. So we have a -4 out here, and then this +5 here at the back. We needed to get rid of that +5 before I get rid of that -4. So, +5, I'm just going to subtract 5 from both sides. Those are going to go away. I'm going to bring down everything else that I did not mess with. So that's going to be -4. Absolute value bars are big, okay? -2x minus 8. Absolute value bar is equal to, now 5 minus 5 is just 0, okay? It's just 0. So now, thinking back to example number 4, and you can look up there if you need to, any number that you have in front of that absolute value bar like that, the best way to get rid of it is to divide by whatever number that is. So we're just going to divide by -4 on both sides. So divide by -4. These -4s are going to become a 1, so we're not going to actually see them. Give me 1 second, I got to put my paper here. There we go. Much better. Okay, so now that those -4s are gone, I'm going to bring down my absolute value, because remember, I haven't done anything to it yet. And then 0 divided by any number is just going to be 0. Okay? Now, we need to talk about this little part right here, because a lot of times over the years, people get here and they're like, oh, Coach Stecker, what am I supposed to do now because it's 0? Can I have a distance of 0? Because remember, absolute value is all about distance anyways. So we have this distance of whatever number this is 0 spaces away from 0. So the only number that is 0 spaces away from 0 is 0. So let's talk about the split, because that's how we deal with the absolute value. So here's what actually happens. If I draw my 2 little arrows to split it, okay, I come over here on the left and I write -2x minus 8 is equal to +0, okay? Got it. If I come over here and I write this side, -2x minus 8 is equal to -0, what's the issue with this? Okay? Hopefully, you've answered me and said there's no such thing as -0. 0 is just 0. There is no negative version of 0. So when you have a problem like this that is actually the distance is equal to 0, you're only going to have one solution, because there is no such thing as -0. So we do not have to solve this one. So we can put a little note right here that says no such thing as -0. No such thing as -0. Okay? So now that we've talked about the -0, if we just solve this, then this is our one solution that we're going to have. So let's go ahead and solve it. I'm going to take this 8, and I'm going to add 8 to both sides. When I do that, these are going to go away. -2x equals 8. Then I just need to divide by that -2 to get rid of it. And so then I'm going to have x is equal to, my solution will be -4. And there we go. So again, I want to remind you, it's okay if the distance is 0. If it's 0, that just means we're only going to have one solution instead of 2. I will tell you though, normally on the state test, they're going to give you a problem like example number 3, okay? And 2. So 2 and 3 are going to give you 2 solutions. That's the one that you're going to see the most. Examples 4 and 5, the ones where we have no solution or 1 solution, we don't see those as often, but they do show up every now and then. I guarantee you're going to see something on the state test about the no solution one. So just be on the lookout for both of those. So what I want you to do now that we have 4 examples done, I want you to do example number 3 on your own. So pause this video, take care of example number 3, do the best you can, and make sure you're writing in pencil just in case if you mess up. And then once you're done with example number 3, go ahead and push play again, and I will show you what the correct answer is. Okay, and as promised, here is example number 3. So I kind of want to talk through the steps that I took and the reasons why I did it, and we'll just double check to make sure that you have the correct answer. So in my little hint box over here, I covered up my absolute value, and I realized I had a -2 and a -8 that I needed to deal with. I got rid of the 8 first. Remember, you always need to get rid of the number at the back first, then deal with any number that's out there in the front. So I got rid of that number. I divided to get rid of that -2, because remember, that's the best and fastest way to get rid of it. So then that left me with this part right here. The absolute value, we don't know what this number is 3 spaces away from 0. So any positive value, it's okay to have. So think about the 3 numbers, or the 2 numbers that are 3 spaces away from 0 are +3 and -3. We need to make sure that we have both of those. So then we just had 2 small equations. They're 2-step equations. We're going to move this 7 and then divide by 5 on both of them. So I'm going to talk about this first one. This first one is pretty straightforward because it was the positive version. You should have got a +2. This other one, though, because it was a -3, when we added 7, gave me a +4. And when I divided by 5, this does give you a decimal, but I prefer the fraction. So please just give me the fraction, and that will be perfectly fine. So you don't ever have to give me a decimal unless I specifically ask for it. So if I don't ask for it, just assume I want the fraction. So we should have got 2 and then 4/5 as our answer choices. So remember, if we were to take these and plug them back in, this equation would be true. And I also want you to remember that they can be written out like this or in the set notation brackets that we have. And if they're in the set notation brackets, this is what they're going to look like. So they're going to have x equals just like normal, but then they're going to have set notation bracket, and then both of these numbers are going to be in there. Sometimes the people put it in numerical order, other times they don't. I always put it in numerical order just because that's the way my brain works. So if they put it in numerical order, this is what it's going to look like. But if they don't, it's no big deal. As long as they have both of them, that's all that matters. So you could see the answer choices written either way. So just be mindful of that, be on the lookout. But other than that, y'all crushed it today. Good job, and I'll see you next time.